This comes out of section 9.2, differential equations with initial conditions, as just to start off by finishing off the example that got cut off in the last one. So we got most of the way through this one and somehow it got cut off at the end, but the antiderivative of this is negative 6 ln of x plus x to the 5 minus 7x plus c. If it passes through 1, 3, then we've got substituting in 1 for x and 3 for y, and we end up solving this thing and figuring out that c equals 9. So the function that we're looking for is negative 6 ln x plus x to the 5 minus 7x plus 9. It satisfies both conditions, that its derivative is here and it passes through this point. So last example here, it says, suppose for the graph g that every point has dy by dx equals negative 6 e to the negative 2x. Find the equation of the graph parallel to g that passes through the origin. I chose this one as an example not because it's particularly different than the last couple, but mainly because they ask it in such a different way, this idea of graphs parallel, etc. You have a differential equation, you're given the derivative, so hopefully your first thought is I need to find the antiderivative of that. If you do that carefully, you'll have negative 6 e to the negative 2x divided by negative 2 and then plus c. So negative 6 over negative 2 is 3. E to the negative 2x plus c. Same thing we've done before, and now we're just said it passes through the origin, so that means it goes through point 0, 0. So when y is 0, x is 0, so 3e to the 0 plus c. 0 equals 3 plus c, so c equals negative 3. Your function then is y equals 3 e to the negative 2x minus 3. It has the derivative stated up above and it passes through the origin, so again it meets the two conditions. We're able to nail down the function. This idea about parallel graphs basically says, you've got one curve, and I don't even know exactly what this curve would look like, but picture a curve that you know better. A parabola, a parallel parabola is just one that has the exact same derivative, the same slope at any given point that you were to look at. These are all different functions, but if I looked at the slope at a specific value of x, we'd get the same answer for any of these slopes. That's all parallel functions means. It means they just have a different constant. The rest of the function is the same, but their constant differs.